Right, so we are wanting to find, using the factor theorem, whether we can factorize p of x is equal to x cubed plus 2x squared minus 5x minus 6. Now the thing is, the key entry point here is the minus 6. Now the constant term is negative 6, so there must be factors of x minus alpha, where alpha is going to be a factor of this minus 6. So then it's a matter of kind of guessing and checking. So possible values of alpha for x minus alpha, right? These are, well, it could be plus or minus 6, it could be plus or minus 3, plus or minus 2, or plus or minus 1. Now, this is a bit crude, and we're going to have to sort of guess and check, and hopefully we don't have to go through all of them before we find one. But at some point, there has to be pairs of values, so it's probably going to work out. The other thing to note is that the x cubed, it's a leading coefficient of 1. So all the factors are going to just have x minus something, so no 2x's or anything like that. So let's have a look. So we're going to test x equals 1. So p of 1 is equal to 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6, which is equal to 1 plus 2 minus 5 minus 6. That's equal to negative 8, so that's not equal to 0. Therefore, x minus 1 is not a factor. Right, that's my conclusion. Well, what about negative 1? I don't know, I have a pretty good feeling about this actually. So if we do p of negative 1, that's equal to negative 1 cubed plus 2 negative 1 squared minus 5 times negative 1 minus 6. That's equal to minus 1 plus 2 plus 5 minus 6. And what do we have? We have 0. Now, that is where the factor theorem comes into it to say, okay, p of negative 1 is 0, therefore x plus 1 is a factor. Now, why is it x plus 1? Well, just note that that is x minus minus 1. So, if you like, our alpha is minus 1 in this case. So, well, then what I need to do is, I can write this, but I'm going to have to use long division. So using long division, find quotient. So we're going to do that. What is it again? It's x cubed plus 2x squared minus 5x minus 6. What would we be dividing by? X plus 1. It's going to be x squared up there. So it's going to be x cubed plus x squared. Bring it down, minus. We've got x squared minus 5x. So that's going to be plus x squared plus x minus 6x minus 6. And so that's going to be minus 6. And as we of course should expect, there is no remainder. Right? No remainder. So just from a bit of an educated guess and check, looking at the constant term of my polynomial, it's sort of, especially if it's a lowish number, I can only have a few factors, so I can start to make a guess using the factor theorem about what's it going to be. So I can now write x cubed plus 2x squared minus 5x minus 6 is equal to x plus 1 times x squared plus x minus 6. Now, once I reduce it down to only having quadratics, then I can simply say, well, it's x plus 1. How do I factorize that? Well, added to positive 1, multiplied to negative 6, it's going to be negative 2 and 3. So it's x minus 2, x plus 3. And there we have an infactored form. Now remember I said that all the constant terms, all the terms would have to be, there's 2, there's 3. right? So if I had, say, on way back up here, started with a check on 3, I may have found one of those values, and then it would have turned out slightly differently, but my final answer would have been the same. Now, if I then want to graph this, I'll just add in a grid, because that would be helpful. If I want to graph this, well, that's easy to do. I know where the intercepts are now. I don't need to worry about the turning points or anything like that, so that's fine. We can all see, hopefully, that it's going to be 1, 2, 3, 4. I'll just do it very quickly. Now, the y-intercept's -6, right? Because if x is equal to 0, its y is -6, so it's 1, 2, 3, 4, 5, 6. So it's going to go through here. My x-intercepts are -1, 2, and -3. It's a bit off, but that's okay. Now, the leading coefficient x cubed is positive, so it's going to come down this way. It's going to go like that. It's x cubed, so it's going to have 2 turns in it, and it's going to go down this way. And so it's going to have a turn in it somewhere. I don't know exactly where. Goes down, comes through here, up there, and there we have it. One too many little kinks. But that's basically p of x, as we knew it there. So, see how you go with some other questions.